Here is the answer for day 1, problem 1. Find the solution set of this equation. Because it goes to the third power, let's use synthetic substitution to find our first root. So we have 1 x to the third, 4x squared, 8x, and then the constant 5. And we're going to divide in a number that we think might be the root. Using the possible roots test, we're going to use factors of the constant term divided by factors of the leading term. So positive or negative 1, positive or negative 5 are our possible answers. Looking at these coefficients, which are all positive, I know not to try a positive number because as I multiply and add, these values down here are going to just keep increasing. We're not going to get 0. I'm going to try negative 1. 1, negative 1, 3, negative 3, 5, negative 5, and 0. One of the solutions is negative 1. At this point, we can take our depressed polynomial and write it back in polynomial notation. Set that equal to 0, and then solve that with methods that we've learned this year. For instance, the quadratic formula. A is 1, B is 3, and C is 5. So negative B is negative 3, B squared is 9, and 2 times A is a 2. This makes negative 3 plus or minus the square root, and then 9 minus 20, which is negative 11, all over 2. At this point, we're ready to write our solutions. One of our answers is negative 1. Another answer is negative 3 plus I times the square root of 11 all over 2. And a third answer is negative 3 minus I times the square root of 11 all over 2. Day 1, problem 2. How many roots does this have? The fundamental theorem of algebra says that a polynomial equation will have as many roots as its degree. So this is degree 4. This has 4 roots.